Tidal wetlands are vital ecosystems for humans, plants, and wildlife, but are increasingly threatened by climate-related flooding caused by sea level rise and storms. Salt marshes in the Northeast and Mid-Atlantic are particularly vulnerable to sea level rise because a variety of natural factors and anthropogenic disturbances inhibit accretion rates from keeping pace with accelerating sea level rise. My study site, Prime Hook National Wildlife Refuge in Delaware, contained wetlands that were largely managed as freshwater impoundments until Hurricane Sandy breached the shoreline in 2012 and forced rapid conversion of the refuge from a once heavily vegetated wildlife sanctuary to mostly open water. Because salt marshes are critical environments for filtering pollutants and nutrients, sequestering carbon, and buffering shorelines from damages caused by coastal storms, Prime Hook used funds from the Hurricane Sandy relief bill to complete a $38 million restoration project. With completion of the project in 2016, 2.7 kilometers of shoreline, dune, and back barrier platform were rebuilt, and seedlings were planted across 4 square kilometers of back barrier to regrow vegetation. I conducted a year-long seasonal study to assess the progress of Prime Hook's restoration beyond its official completion date by comparing the biogeochemical characteristics of a restored salt marsh in Management Unit 2 versus a pre-existing salt marsh in Management Unit 4. I established monitoring plots in each unit to collect surface sediment samples for measuring organic content to compare below-ground biomass, which is an indicator of vegetation health. Comparing data from a restored marsh against a pre-existing marsh allows us to assess the restored unit's progress in achieving similarity with the existing unit, which is a common benchmark of success of restoration projects. Results show Unit 2 experienced more seasonal variation in organic content, while Unit 4 experienced more spatial variation. Unit 2's low marsh showed the percent organic matter had a range of 16%, whereas Unit 4's low marsh percent organics range was only 1.3%. Unit 2's high marsh displayed a greater range of 30% compared to Unit 4's high marsh range of 2.5%. Unit 2's upland area exhibited the smallest range in percent organics with an 11% difference between winter and spring, but Unit 4's upland area displayed the largest difference compared to the unit's other sampling areas. These trends show that Unit 2 does not have the same below-ground biomass as Unit 4, which indicates that Unit 2's salt marsh is still working to achieve equivalence with the natural salt marshes at Prime Hook, so continued monitoring is necessary to assess Unit 2's progress in achieving natural conditions.
Thank you so much, Casey, for that presentation. Get your questions ready, but here's my first question. How did your research on the salt marshes impact your ability to land a position at the EPA, or was there a relationship?
Yeah, so at the EPA, I'm in the Air and Radiation Division, in the permits branch. So my now manager was more interested in, I have a combined education of environmental science, doing a lot of research, but my undergrad degree is in critical theory and social justice, so the blend of the two is what I think sealed the deal for me.
Wonderful. That really is intriguing. So it was your interdisciplinary background that actually combined to make you most attractive to the EPA.
Yeah, for sure.
Fantastic. So just as a quick follow-up before I yield to the audience, if there was a question out there, how do you see your work that you're doing right now as an effort to promote social justice?
Yeah, so my primary responsibility is reviewing permits for stationary pollution sources. So I think that making sure any facility that emits air pollutants is regulated and held to the most stringent regulations possible.
Fantastic.
Protecting community health.
Fantastic. Fantastic. Thank you. Is there a question from the audience? Yes, say it out loud and I will repeat it if necessary.
Yeah, sure. So when you're looking at these two different units, do they have the same other variables like inundation rate and plant type?
The other things that I looked at were grain size and elemental composition, so like heavy metals, and those were different. it just would have been too much to look at other things like inundation and like type of vegetation. But we did see, this is really interesting, in Unit 4, there was clear patterns. Unit 4 is the existing salt marsh. The heavy metal concentration went down as like moving inland, but in Unit 2, the restored site, there weren't any clear patterns moving inland like that. So that was just another indicator that Unit 2 still had a ways to go in like kind of catching up to Unit 4 in terms of pollutant filtering.
Sure, thanks.
All right, you have 30 seconds. Any other questions? All right, let's thank Casey.